This is the Amp Hour Podcast, released June 22nd, 2018. Episode 397.4. An interview with ShadyTel.
Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
And I'm Carl Kosher from ShadyTel.
Hey, I'm Falcon K from ShadyTel.
I'm Nick Burrows from ShadyTel.
Wow, welcome to ShadyTel. What is? I've heard some taglines. So what are the taglines?
We're always in your business.
I first heard about this from Fobs on Twitter, and I didn't know about it before I came to Tour Camp, and I love this idea. How long has ShadyTel been going on?
At least since the first, the inception was around the first tour camp, right around there, where it's like the idea of it was born, and then we delivered phone service at the second tour camp.
Okay, that's great.
Basically about 8 years now.
Yeah.
Okay, that's great. And so if people didn't listen to the early episodes where I was mentioning it, you are basically running lines to every tent and even to a boat?
As long as they apply.
Yes, right.
Yeah, and as long as we have enough wire.
Right.
No, we bring a kayak every year now, and if somebody is out in a boat or across the bay, it's fairly easy. We just pay the line out, and then on Sunday we pay the line back.
That's awesome.
The boat's anchored; it's not going anywhere.
That's
so
right. Well, I just always wonder about the orientation. That's the piece that I wonder about. So.
Oh yeah, we check.
Yeah.
We check. It either the line would wrap around the anchor and we'd leave some slack, or else it just kind of like it doesn't really. It just swings back and forth. It's easy.
Great.
Yeah.
So do you have a line to your boat yet?
So I'm not on the boat anymore.
Okay.
I think Monica and Alessandra are. They applied, I think, or you ran one out there maybe or something. But
Oh, I totally did on the first day.
yeah, so they didn't apply those. But let's talk about the application form because that's another thing I love. So you have to actually fill out this duplicate carbon copy type form. What?
Well, if it's not in duplicate, we don't know where the line should go.
Yeah, since we used the second copy, the yellow copy, we tell everyone to hang it up where they want their phone line.
Got
Since
it.
it's like on the form, you fill out a description of where you want it, but that's always not perfect. That usually gets the installer into roughly the right area. It's like, okay, which of these 6 identical tents are the one that's
right.
actually wants phone service?
Right.
And then we can see by their application that yes, it's the the second one on the left.
Right. And I'm really surprised. So like I'm kind of upper camp, and this thing goes far. I mean, like you're really hauling some wires there. So like, do you have estimates on how much total wiring you do?
We save a lot of wire by using T1 trunks to go over there. We're working on downgrading to either N or L carrier technology for that in coming years, though that's a little bit of work because you can't buy that hardware anymore. But so usually we manage to save most of that. It's not like we're running single extensions across the camp all the time. It's like a few in bulk at once. So
you'll go to a switch, and then that'll be the distribution point for each individual tent. And
T1, and then it goes to a channel bank, and then that breaks out to like a few lines so that we can run just 2 pairs instead of 14? 12.
Yeah.
12.
I mean, this is so outside my realm of. So like, how did you kind of? It seems like you're combining old technology with new. The T1 obviously is not like. T1 is like Ethernet cable type stuff or Cat5 or what?
No, well it should be, but no, it's 1.544 megahertz trunking.
Okay.
So each line has its own time division channel.
Okay.
This is like call centers used to use this in like the 80s. This was the big deal. No, but I mean, and to answer your original question, we probably brought, 15,000 feet of wire with us? ShadyTel actually sets the price of wire on eBay.
Oh, really?
We conduct our orders over a 2-year period before each camp, and when the price of surplus cross-connect wire dips below a certain level, then we buy it, and our order actually moves the market. And
It's like pork bellies. Yeah.
It's like that.
That's fantastic. Oh, man. Okay. And so, yeah, I bring a lot of stuff. And then I remember you were saying there's a lot of old school equipment that you kind of get surplus and refurb. And so how are you finding that throughout the years?
So the equipment lasts forever. The thing that we usually use is an AT&T Definity that we bought surplus perhaps, 6 or 7 years ago, I believe? Do you know?
Something like that.
Yeah, one of us owns it, and we've just been kind of coasting on that for a while. Surplus cards for that. I'm actually looking at one across the room, and I recognize the relays because I built about 400 of those this last weekend for our new Switch that isn't quite ready yet.
Right. And we'll talk about that for sure. Yeah,
absolutely. Yeah. It turns out that very, very, very little changes because the standard is from the mid-50s and the hardware will continue to work basically forever.
Got it.
Yeah.
Okay. Yeah, and I imagine like at a certain point there's going to be a dip as they stop ripping stuff out, right? Like there's probably still a lot of physical lines that are out in the world, but less than they have been kind of sunsetting a lot of that in VoIP.
Yeah, so some of the equipment that we use is actually still in service. It's being removed in favor of other things, but the platform that we use is actually we're using a revision 6 model. The revision 10 model is still in manufacture by Avaya.
Okay. Oh wow. Okay.
Yeah.
Wow. That's great.
The new ones are better, but this works.
So what are some of the challenges of the logistics-wise challenges of getting stuff out there? I mean, you've got the vest, you got the hats. That all looks very.
Yes.
That's the first step, right? You got to have the look, right?
Well, as we like to say, safety third.
Safety third. Yep.
Safety third.
Billing first, form second, safety third.
Good. Excellent. Yep.
And so some of the logistics is due to the fact that it's older gear, it draws a lot of power.
Okay.
So that makes it interesting when figuring out how to get electricity out here in the middle of nowhere. And then also it's big and heavy, which also complicates like what vehicles you can use to transport it.
We're on an island, so you have to take a ferry across,
Yes.
right? You're not going to airdrop this stuff in. Or...
It's often 3 cars worth of stuff.
Okay.
And, I mean, the one thing that a lot of people don't get about telephony is that you have a lot of really long wires, and those wires do not behave very much like short wires at all. So in the past, we've tried to do tricks like, can we avoid having 120 volts somewhere by, like, maybe running 48 volts over an actual just pair of telephone lines? And it turns out that most of our equipment draws too many amps for that to really work, or there's too much just stray capacitance on the cable, and you wouldn't notice it for voice quality over like the entire camp is negligible, but for things like trying to distribute power that way, that's always been one of our biggest challenges. Is everywhere that we have lines, we need to have AC power somewhere nearby, or at least a generator, because you can't
to like just to buffer and retransmit that kind of thing, or what?
Well, it's for things like the channel banks or our equipment. It doesn't work without that, so that's why we're trying to build new stuff. So it's a little bit more ruggedized.
Cool, that's great. And what are you doing? So I've seen we're past years using porta-johns, or is that something else?
That was the first year when we were doing cellular service, and for waterproofing reasons, we had to set up our equipment in a porta-john.
Okay.
Just to keep it out of the elements.
So like low cost, just make sure that you're not getting rained on.
Yeah.
For the sake of tradition, we often put a waterproof phone in those.
Okay.
People often end up having to fish them out though, so we've been trying to find equipment that doesn't have that as a consideration. It can't fall in. It's a problem here.
Yeah. So you are looking at building new gear though too.
Oh yeah.
Okay. So what was the thinking behind that?
So there's a few thoughts behind the new gear. One of the thoughts is that since a lot of us volunteer at the Connections Museum in Seattle, which is a museum of old switch technology, basically before transistorization, there's a few transistorized things too, but things like number 1 and number 5 crossbars. We were trying to build something that was somewhat more in the spirit of those technologies, because those were the platforms that phone phreakers could actually consistently hack on. This was the 2600 stuff.
Okay. Yeah.
Days long gone by, you really can't do that stuff anymore. But we would really like to bring some of that back and take away some of the aspects of like the isolated signaling and data channels, and allow people to have a little bit more fun with the equipment. But the other side of that is that this newer equipment is also a lot less organized. It's designed to be installed in specific ways.
Right.
And
have a tech there, have a very specific SOPs, that kind of thing.
Right, well, exactly, and designed to be installed in particular controlled conditions.
Yeah.
Whereas the old stuff was designed like, oh, we put this wire here like about 50 years ago,
Right,
and
right.
it's not very good wire, but, you know, it's kind of enough to carry this. Let's see if we can make the phone ring. And so the older stuff is also a lot more steady state. It's less software, and it's more of a state machine. I'm giving a talk about that sort of thing tomorrow here.
Cool.
And so it's actually a lot easier to wrap your head around how it works. And I mean, we've always been disappointed year over year in how little hacking people actually end up doing on this equipment. If they even guess phone numbers, they're like in the top percentile of people who break our stuff here.
Yeah, right.
Right, like wiretaps.
So you're hoping to get it to the point of like Captain Crunch whistle type things of like tone generation, that kind of thing.
Eventually we'll specifically enable that. We also plan someday, maybe not this, certainly not now, but maybe not this coming 2 years, but long range plan to have like hackable radio trunks and stuff.
Nice. Yep.
Yeah, we really want it to be like the 50s and 60s era of this, where like if you had enough technical knowledge, you could easily just go and tap into a line and wreak all kinds of havoc, or like get your radio out and you know, listen in on people's car phone calls.
Nice. Okay.
Yeah, all this technology is long gone, but we're trying to have.
So it's almost like a downgrade of tech in order to enable more mischief.
Oh yeah, that's totally what we're about. You
Yeah.
won't see us implementing LTE anytime soon.
right.
LTE is too secure.
That's right.
And it's too simple. It's just like all IP.
Yes,
Right,
it
exactly,
is
yeah.
all IP.
Right.
That's the migration path, and this is all circuit switched.
Right.
And you know, you provision things and you have capacity. Of course, this isn't as much about capacity, but it's about remembering all of these old vulnerabilities and why we made the systems the way they are now.
Well, then also it's like sometimes you can tell like differences in voice quality because in like these switches, it's like it's a relay, so basically you have a dry line all the way to the person you called.
Yep.
No
Where-
filter.
No
Nope.
codecs, no nothing, right?
No nothing.
Yeah, that's great. You know, and so like as obviously our podcast quality tonight is not going to be great, but like as someone who listens to like audio a lot and just like kind of struggles over that, and like even Skype these days, right? It's just a pile of crap. I miss the picking up a phone and it sounds like someone's there. You know, like that is there's like some kind of thing about that as well that you just don't get anymore. You know.
Yeah, so the Speaks codec that they use is designed to transmit phonemes, and it does, but it doesn't transmit a lot of the character that an actual audio connection would.
Right.
So
Right. Actual like 300 hertz of 3,000 hertz of
2
actual.
kilohertz.
Yeah. Yep. So like that. Yeah. That I missed that. Yeah, and so do you all have experience in the phone freaking hacking type days? I mean, is that how you got kind of into this, or? I'm not saying you're older than you look. I'm just saying that is it like something that you've
Oh.
practiced in, you know?
No, I know my beard is long, but
It's you're not a gray beard. You're saying, yeah?
no, it's my leaf beard from. But no, it's not about that so much. I was born in the 90s. There was none of that then. But what it is like we don't remember it ourselves, but like all of the documentation for the technology is there. I mean, I mentioned the Connections Museum just a moment ago.
Oh, right, yeah.
It has a complete set of documentation to which we often refer for each of those old switching technologies: panel switch, step-by-step switch, number 1 crossbar, number 5 crossbar, signaling system 5. This is all stuff that's known to us, and these things that people used to steal out of the back of a truck, now that it's no longer commercially viable technology, we can just look at it and have
there's no
working
trade secrets
models.
anymore. You're saying,
Well,
right?
I'm sure that there's still trade secrets.
Well, yeah, right.
We're not supposed to take photocopies, but we can just read it
Yeah.
and understand how it was designed. And
Yeah.
I mean, you can't design stuff like that anymore. This stuff was designed with no vacuum tubes. This stuff
Right.
was designed like, oh, we need a 15 Henry relay in here that is ridiculously large, by the way. Let's
Right.
just like route the signal through this relay coil. We can't do that. That's not feasible.
Right.
So what we're trying to do is design our system kind of in the spirit of that, so that people here can experience what it was like to have that system. I mean, there are certainly people here at TourCamp who have never used an analog telephone for anything ever. They've never needed to. But here, like, they can call someone else's campsite and see if they have any whiskey.
Right.
Yep.
I
Or
was-
ask them if the refrigerator's running.
Well,
Classic.
Yes.
Yeah. I was saying that so when I picked up a phone from just a Goodwill down the street because I didn't want to carry it with me on the plane. But I was saying like I dropped the phone by accident and I was like, oh my god, that resonant ring of like the handset hitting the hook. It's like, oh man, just like hanging up on someone is so much different now, right?
Yeah.
Yes,
you're like,
it is.
You're like angrily pressing the button on your touchscreen. It's like that doesn't do it. You slam that shit down.
All that old stuff was so over-engineered, you could have used it like that.
Yeah. Well, yeah, these things, right? I got one here.
Oh, yeah.
Oh, yeah.
We have a billion of those in here.
Yeah. Oh man. these things
We
are-
buy those surplus too, but we
Yeah.
haven't set the price for them. A lot of them
Okay.
come from old hotels.
Yeah.
They get sold at surplus.
Oh god, imagine how much bacteria is on those things.
Yeah, a little bit. It's just Bakelite. It's not resistant. So.
Oh man.
Yeah. Those are actual 2500 sets. There are a number of different kinds. There are some that are transistorized. There are some that are still inductors and capacitors to generate tones.
Oh nice.
You can
These
still buy
are relay phones too. You can still buy actual 2500 sets, of course.
2500 is the model number.
Yeah.
Yes.
Okay.
Exactly.
new off of Amazon.
Really? Okay.
Yeah, they're made by Cortelco now,
And
who
that-
acquired them through
Right.
a bunch of
Various
Of
intermediaries.
course. Right. Wow. That's nuts. And there's still use cases for it, I guess. I mean, I guess there's still analog lines out in the world, right? So like,
Yeah.
so let's talk about the analog line itself too, because so that has, and that's the thing that I think a lot of people are these days are like, oh well, you don't need anything else to plug into it. So what is the voltage levels that you're delivering to
Yeah,
each?
it's actually quite interesting since normally people think, oh, it's 48 volts and stuff like that for teleco, but it actually isn't. What it is it's actually 20 milliamps.
Oh, okay, so like a 4 to 20 type,
Yeah.
like a transmitter,
Yeah,
right?
and then so basically the handset usually nominally runs at about 6 volts.
Okay, right.
And then so if you can give it 20 milliamps, you can power pretty much any
Right.
analog phone and then basically set up, basically a hotline or something like that. You won't get ring.
Right.
But if you want ring, that's where some complications become in, since that's 90 volts at 20 hertz.
Oh, okay.
So
Yeah.
generating that's kind of annoying.
90 volts at 20 hertz or 20 milliamps?
20 hertz.
Okay.
The
And
current is not really specified for
Okay.
that.
Yeah,
all right,
but usually the current for the specifications, if you go from what's called RIN, which is what the units, Bell specified their ringers in.
Wait, what
it's
is it?
RIN, ringer
Ringer.
equivalent number. and then there's a
Oh man,
for
don't
that.
you guys miss the vertically integrated days of where
No,
you're like,
so-
we're just gonna make up our own thing. Who
And
cares?
wasn't one REN equal to a single Model 2500?
Yes,
something
that was
like
the reference.
Right.
And
Yeah,
so
Right,
yeah,
you have
but
like
it's
a
like a
golden
50s
telephone,
one.
right?
they measured it from one that they made and made the unit. So
Yeah.
the beautiful thing about a lot of the design of this equipment, there's really two the two beautiful things about this line of equipment is that back then they were able to design, it was just some engineers, and they were able to design whatever the hell they wanted.
Right.
This was actually a thing that, to a point, talking about some history here that some people taught me at the museum, they had a capacitor design committee. And the capacitor design
God.
committee's purpose,
Yeah.
this was actually a massive business efficiency for them, because previously the engineers were like, yes, clearly this value, 4,326.25
Right,
farads
right.
is the capacitor that should be here. And Western Electric had to make all kinds of varieties of capacitors that may have been used only in one component of the design, so one per central office. So there were less than 200 of these capacitors in existence, and they all had to be that value, and they were always
Right.
like, oh yes, 1% tolerance. So the capacitor design committee's purpose was to say, no, rein them in, and say, no, standardize. And that's where we actually ended up getting the thrust toward the standard
E3,
capacitor values
E6,
from.
all that stuff. Yep.
Yeah. The logarithmic cadence that we have now, the decades, that comes from that, hey, wait, we actually don't need them to be this precise. We can compose them and save huge amounts of money.
Yeah.
The other thrust of this is that a lot of modern electronics design, I'm looking at a board that I've designed now, and all of the components are basically standard. Right? Everything is basically either, logic is always basically MOSFET, voltage or potential driven, charge driven, technically, but voltage driven if you want to be reasonable about it. The amplifiers are all current driven, and it's just like that. We conventionally design with no inductors, and we use op amps to substitute where we would otherwise have them.
Oh right, no
Yeah.
custom circuit magic that
Well-
some PhD loves to show off with, right?
But so back then, the reason that you get this distribution, you have it could be at least 0.6 volts, but it has to be 20 milliamps, or the notion at all of having a current loop, which is a very cool thing. This used to be used for telegraphs. Sidetrack here. A current loop is basically for very long lines intended to be voltage insensitive because, of course, current is conserved.
Right.
So as long as you have enough voltage to make your components work across the loop, it doesn't really matter how long the line is.
Well, it's still done in
beautiful
industrial
technology.
stuff, 4 to 20 converters, right? Or transmitters, right?
Exactly,
Yeah.
but like, you know, for most consumer electronics, this is just not even a thing that you would think about implementing
Right.
because it's hard to use. But back then they were just like, oh, there's this fundamental electrical property that we could just use here.
Yeah, right.
Which is how you end up with, oh, this relay happens to have a 15 Henry inductor on it. Let's use that because
Right.
that blocks voice.
Right, right. Wow.
So if you want to supply battery to a line, you wonder why, like, you're all on the same battery, you don't hear everyone talking. There's a 15 Henry inductor in series with you to the battery.
Wow.
You can't make those anymore.
And just for the people who don't normally specify inductors, it's basically all a 15 Henry inductor is
Right.
also like specifying a 15 farad capacitor.
Right,
You know, they're
exactly.
massive.
They're coils of wire, right?
Yeah, yes.
Yes, gigantic coils of wire. That
Yeah.
that component
Pounds
weighs half
of
a
wire,
pound to a
right.
pound. Yes.
Yeah, right. Wow, that's crazy. And so where would that actually, that 15 Henry inductor, where would that go in the system?
In series with the connection to the battery.
So in the cabinet though, at like the at the transmit
in
point?
general, yeah, there's a thing called the central office. They actually still exist.
Okay.
Said museum is on the top floor of one. CenturyLink graciously gave the museum that space.
Nice.
And power to go with it. But these offices were built. They were often disguised as houses or as warehouses or whatever, well hidden behind a lot of trees. Nondescript brick buildings, and in them were just racks. So here's another piece of history for you. One U, as in a
I
U
was
from
wondering
a
if you were going
rack.
to get to that. Yeah.
Yes. One U comes from the height of a row of relays.
Uh-huh.
This is why it's such an odd number.
Right.
It's because they made the relay. The relay had so many pins on it.
Yep.
And this is how tall it needed to be to work and have isolation for the 48 volts across it, sometimes 90, 96. 110 is nominal ring even.
Yeah.
Because it runs a little hot at the central office. It's like 55 volts where it should be 48, and it's like 110 volts where it could be 90. They built a lot of margin for error into these systems, but that's where 1U comes from. It's the height of those components, and they started building everything like that.
Yeah, and that's the thing, that now it's just an ad hoc standard that cheap hardware drives other adoption, right? You know?
Absolutely.
Yeah.
This is the standard. We'll do this for the next thing and the next thing and the next thing, and now all of a sudden
And now you don't know where it comes from.
we
right?
have
Yeah.
entire like massive transistorized virtualization rigs running
Yeah.
multiple computers in them, and they're the height that they are designed to comes from
right.
this stupid relay.
To be fair, some of those are probably still doing voice.
Yes,
Right.
a couple.
Yeah, right.
Maybe.
Right. AI analysis of voice, right?
AI analysis of voice is more likely.
Yeah. So let's talk about the hardware. So the hardware did not work for this con, but
Well,
that's okay. Hey,
Hardware is hard.
we applaud that here at the Amp Hour.
Oh.
So let's hear about it. So there is a bunch of circuit boards around me too. So
Yeah, a lot of them.
Are these all like modules, or what's the idea?
Yes.
here?
yeah,
So-
so go ahead. We modularized the design. I initially started designing it. This is actually my first major project ever in this. I'm a software guy. I'm not even an engineer at all. In Canada, it's a regulated profession, and I can't call myself an engineer.
Well,
but,
we're not in Canada right now, are we?
No, we're not.
Very close, but not that.
Yes,
Yeah,
anyways,
right.
so I initially tried to design this whole thing on one backplane, being like, headers are expensive, I hate them. And we found very quickly that it was absolutely necessary to break each function out into various modules, because otherwise it became an unmanageably large schematic. There are too many wires all over the place. The board was just too large
Yeah.
to actually bother to lay out.
Right.
And
Well, and I think about the replacement as well. That's a big thing. So, like, if you're troubleshooting
Yeah.
and you need to replace, having hot swappable is actually really great for that kind
And
of thing.
then it's also like the design for manufacturing is when we manufacture it, you have yield problems.
You're right. Yeah, of
And
course.
so when we make one of these modules, we test each of these modules individually, so we know that module is good and working before we integrate it further in manufacturing. So we don't run into the problem of building this huge board and going, oh crap, it doesn't work. How do I even figure out
Exactly.
what one of these hundreds of circuits is faulty? Where with a module, we can plug it into our testers we've built, which we
Yep.
didn't bring with us.
Yep.
But we can plug it into our tester and then see if that module works or not.
Nice. Well, and so like the one obviously people listening cannot hear this, or kind of see it. But this one is the Tone Plant V2.2.
Yes. The last thing that I do with each of these designs is I put a few stamps on them. It's a way to motivate myself a little bit to actually finish them. I once I'm done, I find some spare space on the board and put a silkscreen annotation with what it's for, and I put at least a couple of ShadyTel logos. Sometimes they're buried under chips.
Right.
But so that one is a imprecise tone plant, I believe. Am I right?
That's right. Yep.
So our attempt to this small amount of modesty, we went through about 6 iterations on our tone plant. Basically, all of the digital modules of the circuit have gone through no more than 2 revisions. All of the analog modules in the circuit have gone through the ones that work no less than 6.
That's
and
good.
so that component is actually a DTMF generator.
This one I'm holding. So a different board here.
There is that one. No, the old
tone
one was a
plant.
DTMF
Oh, the tone plant
generator.
is okay.
Yeah, it could be other things. It could be a precise tone plan generator that could generate ring. It could generate busy, depending on what resistors we put in there.
Got it.
I made sure that it was the case that every tone could be indicated by at most 1 resistance, so that it was possible to adjust and modularize.
So you have different modules though.
Yeah.
And then this is then plugging into some larger motherboard type of thing.
Backplane.
Backplane, okay.
We almost finished making one using perfboard, and then it was time to go catch our ferry. So
Oh my god.
the deadline goes.
Wow. Yeah.
It passes, and
No, this is great though. I
Yeah.
really love this too. And sorry, do you want to introduce yourself too for the? So we have a new entrant into the ring.
My name is Thumbfreaker. I'm to some degree the architect of the current network.
All right. Well, welcome, Thoughtfreaker. So
there.
thank you for coming. We're just talking about the newest stuff, but quick overview of what the network architecture looks like.
So at the moment, the network is running on via Definity. It's like it's a circuit switch version of a product they sell now called Communication Manager. It's basically like a mid-sized PBX. You usually see in like offices or hotels and such.
Yeah.
And there's a few other like peripheral nodes that we use, like channel banks, which are like basically, it's like almost like an external sound card for your computer. It's like you can convert a bunch of analog lines to like actual analog lines from a serial for like a serial data stream, like later on down the line, just kind of conserve wires.
Yeah.
And as well, there's like this IVR unit running on like a Dialogic card, which is it's fairly strange hardware. Basically, it's like a little this particular one is running on an i960, which is running VxWorks, and it has like a very large amount of Motorola 56K DSPs and also a PCI slot.
Okay. Cool. And that's the stuff that's kind of scattered about camp and also back here. Are we at headquarters right now? This is
headquarters.
Headquarters.
TorCap graciously gives us this cavity
That's nice,
tier in
yeah.
order to run our equipment out of. It doesn't like the rain. We're working on that problem.
Okay. Conformal coating is a thing, yeah?
Yeah. Yes. Well, we can do that. We just don't have anything to coat, and we can't coat that thing because it has a lot of
And
fans.
just keep spraying.
Yeah. No, it's it can't be sealed.
Ziploc
so-
bags or
Yeah, we've been trying to economize a lot on current actually, so that we don't have heat problems.
Yeah.
The single biggest component in our design that draws current, the single biggest component that draws current in the Definity appears to me to be the fans. Although there's a lot of ASICs in it that might be FPGAs, and they could be doing that too. But anyways, so we're trying as hard as we can to economize on current, and so the biggest current draw in this is LEDs. And so we found that basically all major logic families, that doesn't even have the most LEDs, but all major logic families now that we have used, HC to AHC, they all can tolerate things like 9.1 megohm pull-down resistors. It doesn't matter, especially when we're working at the kinds of frequencies that we are, which is you have to not notice that there's a glitch as you pick up the phone. It's really not a big deal. You have about a second, which is, even 7400 series, like the old stuff, would work for this. So we can get away with things like that. All of my voltage dividers, if I need one for like a Salin key filter, the voltage dividers in it may be like 1 megohm or at least 100K. And it's just kind of reducing the passive drain of this. Also, one thing that saves us a lot of current is in our attempted design, unlike things like the Definity, we're trying to do it without any microcontrollers, which means that the current draw is astonishingly low because we don't need the high current that's required to drive all of those transistors in the large modular design that a CPU is that could do anything. Ours just does this one simple thing.
Right, and it seems like a lot of small boards that kind of build up to that main thing.
Well, exactly, and each of them has their own discrete function. There's one that's just a relay and it's protection diodes. There's a few that are just a register that registers one 4-bit BCD digit. The one that I'm holding in my hand is by far the largest. It has a pin header that I believe is 44 pins wide, and this one is kind of its brain. This is it. Actually, there was a failure here and we specified the wrong package, so we couldn't make them in time. But this is the thing that manages all of the state. It has a counter on it, and I just plotted out K-maps for everything that was contingent upon that counter, and it took like a week, and then it was done. And now it's this, and it has about 50-odd components on it, which is kind of a pain to assemble. But on the other end, the magic of resistor nets for all of my pull-down resistors works well to reduce that number considerably. But we magnify that number a little bit by doing things like a lot of my Boolean functions I optimize for OR versus AND. So I have a few inverters, which are small. You know, you get more inverters per chip than AND gates, for instance. And I have a lot of diodes, which are operating as OR gates. So we're using partially literally diode resistor logic without the AND half of that because you need another power rail to do that. And it turns out that modern logic as well is completely tolerant to cascading diode-based OR gates too deep, and it doesn't care.
Just because of the logic levels are pretty tolerant, you're saying?
They're so tolerant.
Yeah.
It's beautiful how tolerant
and
they
the
are.
really nice hysteresis and
Right.
Schmidt trigger inputs and all that
If
stuff.
I need to cascade them further, which I generally don't if I design that out, they rarely cascade more than one. I just put a Schmidt trigger buffer in there, and it's perfectly fine. I could bias it, but I'm lazy.
Yeah, no, so this sounds like a really good application of like people that are looking to learn analog stuff, looking to learn digital logic. It seems like there's a lot of that, like, I mean, obviously that's where it all came from in the first place, right? You mentioned Allen key filters, a lot of the filtering mechanisms that people know about, op amps, all those things are just kind of come from telephony and similar spaces.
Well,
right?
and also like for providing battery power, we're using a current mirror circuit. It's just straight out of the art of electronics,
Yep,
and it works
exactly.
beautifully.
Yeah.
It's two transistors.
Yep, yep.
And it's like we could use a 15 Henry inductor, or we could use two transistors.
2 weeks later, you're like, oh god, so much wire.
Well, because you can't buy these things. You have to wind your own.
Yeah,
And
exactly,
You
exactly.
don't want to be doing that. But
Well, and I think so. That actually brings up probably my last question, unfortunately, because I'm running out of recording room.
course.
But how is this funded? How is it self-funded, or is there like donation-based stuff? Or
yeah, we all work in information security in Seattle, most of us. So like we just do this over 2 years. A little project like this is not that big of a deal.
awesome. Okay,
Yeah. I mean, you can get boards printed real cheap.
Oh, we know this on the Empire, yes.
Oh, yeah. we have a few suppliers. We used to use Oshpark for most of our prototyping. Right now, we're using a lot of two suppliers. I'll name PCBWay and PCBCart. PCBCart charges us a punitive tooling fee, but if we know the board is finalized, then we get to like order them for maybe 5-10 cents a board forever.
Right.
PCBWay is basically Oshpark's model. A lot less service from them, but a lot more options and about. It really depends whether Oshpark or that is cheaper. Depends on your board, but
Right.
and on what you want, and because we can forgo most of the fancy options with this stuff, right? Analog, simple logic. Most of it, to be honest, is DC. We don't really need the gold. We can do fine with hot air solder leveling.
Yeah, right, right.
Yeah.
Awesome. Well, this is a hell of a project. I'm really so. Are you guys going to any other? Do you do just tour camp or is other stuff too?
So far, just tour camp.
So like, if
It's a lot of stuff to carry
it
around.
does sound like a lot of stuff.
Yeah,
to carry,
every
right.
2 years. It's really exhausting to prepare for it, so we don't
Yeah.
usually... However, one of the reasons that we're designing the Switch is weight. The Definity weighs,
Yeah.
what is that? It must be at least 200 pounds.
That's not that heavy. It's
Okay.
like 60 kilos.
At
Yeah.
least.
But with like the bulk and the, I mean, if you're doing the wire
it's
anyways,
bulky.
right?
It's
Yeah.
almost more than I can
Yeah,
carry.
it's like a centimeter narrower than the standard door frame.
Oh,
And
yeah.
so
So you can just like
Yeah.
barely
Yeah,
get it
yeah,
through
yeah.
a
It's
door.
like, what, 20U. So we got invited to Shy, and we were like, we can't go because we can't take our equipment with us on the airplane. It's too heavy to fly.
Right, you definitely have to drive it. Yeah.
Well, so what we part of the reason for this is we can break it up into small components.
Yeah.
It's really light. I could make it lighter if I wanted to, simply by specifying thinner PCBs.
right? Yeah,
It
right.
doesn't have a gigantic steel frame. It doesn't need fans,
right.
so everything is passively cooled because you
love
can do that.
Are you putting design files online anywhere?
Yes. So
It's actually open source. We haven't licensed it yet.
I just
but,
meant from peeking at it kind of thing.
Yeah,
so.
our current design as of today is currently on Upverter as the nonprofit that we run this all under, called Northwestern Telephone and Telegraph.
NTT. Yeah.
Yes, NWTT. NTT is
okay.
taken.
Okay.
Yes, but the NWT&T Co. and its manufacturing arm, Northwestern Electric. But
Very nice. Yeah.
yes, absolutely. We're in the middle of switching to Altium Circuit Studio, so I don't know how easy it will be for us to make those designs open.
I mean, I have a very good option for you, but it doesn't sound like we talked before the show. It didn't sound like you're into it. But
We're still very much
more lobbying to be done after
Yeah,
the
well,
show.
but also-
I can lean on them
Okay,
for you know
great,
the next
great.
2 years.
See if we'll switch to KiCad.
Okay,
Yeah.
Yeah.
I'm
we'll
still
get
in
there.
flux for
We'll
what
get there.
design software
But
I
also,
most
like for the test harnesses, we've been using microcontrollers just to speed things up
Sure,
because we're
yeah.
pressed for time for the Stewart camp, and all of that code's available on GitHub.
Nice. Okay.
So under like the MIT license, I believe.
Is there a ShadyTel? Is there, or is it an NWT?
It's just a random one.
Okay.
I think it's like if you search for the Shady switch, you'll find it.
Okay. Great.
So as we do this project more, we'll be uploading all the design files, all of the test harnesses that we use
Right.
for manufacturing, the jigs we used for building the relays back before we got a solder pot to do
Very nice.
pin header soldering.
Yeah, that'll
know more.
That'll change your life.
I
Right?
don't have
Yeah.
a solder pot this big though, so.
Yeah.
Yeah.
You need
So-
to get a fountain at that point.
Yeah,
right?
but
Yes.
prior to that, we 3D printed jigs to hold.
Oh, we're
the
buying
relays.
a pick and place too.
Yeah.
We've
Yeah.
had enough.
Yeah.
So we 3D printed jigs to hold the relay and the pin head, since it's a right angle pin headers, and you know those like falling out.
Of course.
So we 3D printed a jig that would hold all of those in place while you
While you're
manually
doing
soldered
it,
it all
yeah.
together.
And then the solder iron melts the jig, and you
Yeah,
need to make a
right.
new one.
Right,
You know,
right.
they're cheap. They're just
but it lasts.
3D printed
but
jig.
it
a few
lasted
hundred.
about lasted about 100 ones, and you just print another one while you're soldering. And,
So,
and all of those are open source. I think the jigs are on the Onshape online free tool.
Cool. Is there a centralized place people can find out more about ShadyTel?
Tour camp.
Come to TourCamp. Yeah, that's a good start.
Yeah.
Is there?
I mean, we have several websites. I'm not sure which one is the definitive.
Shady.tel is the definitive one.
Okay.
It also
Yeah.
has all of our branding and
Awesome. All the propaganda arm that I heard about.
yeah.
Yeah.
Absolutely.
All right. Well, thanks for being on the show today, guys. I appreciate it.
Yep, thanks.
Thank you.
All right.